Okay, good afternoon, boys and girls. Today we're going to go over simple rules for nomenclature. This is the stuff we've been working on for the past week or so. And so this is basically just a podcast to reinforce some of that. Okay, before we start, we need to go over a few terms. So we need to know these things before we start off. And so I'll go over them and give a couple examples for each one. First thing is, you have to know what an ion is. An ion is just a charged atom or group of atoms. Okay, and it can have one of two possible charges. It could be either an anion, which is a negatively charged ion, or it could be a cation, which is a positively charged ion. Okay, charge. Well, atoms and ions can have charges that are either positive or negative. Usually, the negative things are anywhere from -1 to negative, I guess I've seen some stuff -4. I'm trying to think, have I? I don't know. It's not too common to go over that. For the cations, though, the charges can go anywhere from +1 up to, I know of one that has +7. Okay, and you also need to know what neutral is. And neutral is when the charge on the anions equals the charge on the cations. And this is true for all compounds. All compounds are neutral. So we know that when we write the formulae for these compounds and we indicate the number of anions and cations, we know that the sum of them has to be 0. So compounds are neutral. Okay. What do I need in order to proceed here? Okay, so we want to learn some nomenclature. I'm suggesting that you should have your periodic table. Okay, so this is our periodic table, and there's some information that we need to make sure is on here. Number one, we need to make sure the anions, the simple anions, the charges are written beside here, so -3 and -3 for nitrogen and phosphorus, -2 and -1. And over on the other side, we've got the alkali metals at +1 and the alkaline earth metals at +2. Those charges are all over on the back of your periodic table, just here at the top. So the cations are here and the anions are over here. Okay, speaking of the back, we've got the polyatomic ions listed here. It's certainly not all the polyatomic ions, but it's the ones that we'll see, the common ones. Okay, you're also going to need your flow chart, and this is the one that we're using this year. Basically, it's just a sequence of questions to ask yourself. So you start off by looking at the name, and then from there on, just depending on what features the formula or the name has, it basically tells you what to do. So in order to make this table useful, we're going to put a couple reminders to ourselves in here. And the table is actually, there's one on the front and one on the back. One's name to formula, the other is formula to name. And the questions are actually the same on both sides. It's just the procedures are different. So to start us off with, contains a metal. And just as a reminder to yourself, those are on the right side of the staircase on your periodic table. And for these ones, you're going to need the prefixes. And the prefixes are mono, di, tri, tetra, penta, hexa, hepta, octa, and nona, and deca. Okay, these ones right here that's supposed to be penta. These ones are going to be reused when we talk about organic chemistry. These ones you're only really going to see in this unit, or when we're talking about molecular compounds. Okay, so if it contains a metal, if the answer is no, it must be to the right of the staircase. If the answer is yes, we're to the left of the staircase. And the first question is, contains a polyvalent cation. And those are the things like iron, where it can have more than one possible charge. And we'll take a look at the periodic table and how do you tell that in a little bit. The other thing is, contains a polyatomic ion. Well, if the answer there is yes, a polyatomic ion would be something like nitrate, NO3, -1, or sulfate, SO4, -2. And we could write the names as well as the formula in there. Okay, if it's not a polyvalent cation, it must be just a simple cation, something like calcium, just one possible charge, 2 positive, or sodium, for instance, 1 plus. Okay, and the next question down here is contains a polyatomic ion again. And so if the answer is yes, we're basically at sulfate or nitrate. And if the answer is no, it's it's going to be something like a chloride ion or maybe perhaps a sulfide ion. Okay, and the same thing is true up here. If it's a polyatomic ion, it could be sulfate or nitrate, or let's put bromide down here, or as an example, a nitride ion. Okay, we're going to transfer those questions, the answers to those questions, the little hints here that we've written in here, the examples. We're going to transfer those over onto the back of this sheet and continue. I've done almost all of them, just complete right here, so chloride or sulfide. So the questions are basically the same on both sides. It's just over here in the procedure that's different. Okay, basically there are 5 types of compounds that we're going to be practicing naming here. And the first type that we're going to be doing are the monovalent cations and the simple anions. Okay, so the monovalent cations are examples like calcium or sodium. And the simple anions are like chloride or perhaps oxide ion. Okay. And now in order to name these, we're going to get our flowchart out here, and we can kind of trace through. So we're going to be writing the formulas for the first section here. And so we've got our piece of scrap paper here to practice on. We've got our flowchart here, and we're going from name to formula. Okay. And so the first one here is calcium fluoride. So we look at the name, calcium fluoride, and we have to decide if it contains a metal or not. So by this point in time, you probably know that on the periodic table, calcium is over here on the left-hand side, so it's a metal. And so the answer is yes. So we come down to the next question, and is it a polyvalent cation? That means, does it have more than one possible charge? And the answer is no for calcium. It just has a charge of +2. That's all it can have. Okay, and so we come down to the next question. And the next question is, does it contain a polyatomic ion? Well, those ions usually have 8 and 8 endings, and those are located on the back of your periodic table. Well, this example, the one that we're doing, is calcium fluoride. And so when we look on here, we see that fluoride is actually one of these simple ions. It's not a polyatomic ion. So the only 3 polyatomic ions that we have to deal with that have an IDE ending are these 3 right here, hydroxide, cyanide, or peroxide. Otherwise, if it's an ide, it's a simple anion. Okay, so that puts us down here. We know that it's a simple anion. Okay, it's like a chloride or a sulfide. So what we're going to do is write the first atom symbol with the charge from the periodic table. Then we're going to write the second atom symbol with the charge, again from the periodic table. And then we have to make the charge on the anions equal the charge on the cations. And we can do that by adding subscripts and, if we need to, brackets. But in this case, we don't need brackets for these examples. So number 1. So we write down the symbol. So from the periodic table, the symbol for calcium is Ca. And our charge is written right up here underneath the electronegativity value, and it's +2. So calcium +2. Then the flowchart asked us to write the second atom symbol with the charge, and our second atom symbol in this case is fluorine, and its charge from your periodic table is F-1. Okay. Now the last thing we do in the flowchart is we have to make the charge on the anions equal to the charge on the cations. And how do we do that? Well, let's count up here. We've got 2 positives and we've got 1 negative. That means we're going to need a second negative. So 2, we put a little F2 down below here, a subscripted 2, and that means 2 fluoride ions for each calcium ion. Each fluoride ion has a -1 charge. If you have 2 of them, that's a -2 charge. And the last thing we need to do is just clean up the formula by writing it without the charges. Okay, let's go on to the next one here, sodium chloride. When we look at the periodic, or rather the flowchart here, you'll notice that everything in table number 1 winds up in the same place. So they all contain a metal. None of them are polyvalent. They don't have a polyatomic ion in them. So we're just going to be practicing through repetition this. So write the first atom symbol with the charge, write the second atom symbol with the charge, and the charge on the anions has to equal the charge on the cations. So that's the rule that we're applying here. Now, some of the other things that you're learning is the location of things on the periodic table. So, where is sodium on the periodic table and what is its symbol? Okay, if you haven't looked it up before, sodium is on the left-hand side over here, Na, and the symbol is Na, and the charge on it is +1. So we write Na plus 1. Write the second atom symbol with the charge. The second atom symbol is Cl, and the charge from our periodic table is -1. So we write a little -1 in beside. Now, the anion, the chloride here, the charge on it has to equal the charge on the cation, the sodium. So it does right now, +1 and -1, so our formula is just NaCl. Number 3, barium bromide. So we look up barium, and barium is Ba on your periodic table. It has a charge of +2. It's over by the it's the alkaline earth metals. And the anion is bromine, or bromide ion, and it has a charge of -1. So we have to make sure the charge on the anions equals the charge on the cations. Right now we have +2 and -1. We need to put a little 2 down here. 2 times -1 is -2, and that cancels out the charge on the barium. So Ba, Br2. And the reason we're doing that is the charges on these compounds always has to equal 0. Okay, on to number 4. Number 4 is calcium oxide. Calcium +2. Oxide has a charge of -2. So it's just going to be CaO. Now, as you go through, I've got 20 examples here. You're going to practice all 20, and then you can flip the sheet over on the back and check and make sure if you've got the correct answer. So calcium fluoride, NaCl, barium bromide, and calcium oxide. Okay, and basically, you're just going to go through and do the next 20. Okay, we finished up table number 1. We're headed on to table number 3 now. And these are just slightly more complicated. We're going to start to see brackets when we do table number 3. So let's take a look at question number 41, or sample number 41, and calcium sulfate. So we use our flow chart again. Look at the name. Does it contain a metal? Yes, it is. Is it polyvalent? No, calcium is not polyvalent. And so we come down here. Does it contain a polyatomic ion? Well, it was calcium sulfate. Yep. And that definitely has an 8 ending, so it must be a polyatomic ion. And if we look at the back of the periodic table, we'll see that the formula is SO4 -2. So this is what we're going to do. We're going to write the first atom symbol with the charge. We're going to write the polyatomic ions formula with the charge, just like we did before. And we're going to be putting the charge on the anions equal the charge on the cations. And the only difference here is if we need more than one of these polyatomic ions, we have to put brackets around them and then write another subscript on the outside to indicate how many. So let's take a look here. The first one is calcium sulfate. So we have to write the first atom symbol with its charge. So 41, Ca, 2+, and that's right off the periodic table again. On the left-hand side, calcium there with a +2 charge. You're going to be flipping back and forth quite a bit. And the next thing to do is to write the polyatomic ion formula, and we use the periodic table for that. So if you don't know sulfate, sulfate is located right here, and it's SO4 -2. So SO4 -2. And so we have the cation and anion written out, and now we have to make sure the charges are equal. So 2 positive and 2 negative. The charges are equal. We can just write down CaSO4, and that's calcium sulfate. Let's take a look at the next one. 42 is beryllium nitrate. So beryllium is in the same column on the periodic table, the same group as calcium. It's the alkaline earth metals. It has a +2 charge. Nitrate on the back of your periodic table is NO3 -1. And again, if you look this up a few times, you'll get to learn that. So NO3 -1, nitrate. And now we have to make the charge on the anions equal the charge on the cations. And the way we do that is we add some brackets around here and a 2. So we have 2 nitrate ions to each beryllium ion, and so we get Be NO3 2. Okay, question number 43 is ammonium chloride. This is the only example really where the flowchart breaks down, and that's because the ammonium is a polyatomic ion, and but it's a polyatomic cation. And if you use this flowchart, you wind up over here trying to name it as a molecular compound. So we're just going to use the same procedure as we used with these other ones. So ammonium, and you don't have to look that up on the periodic table. That comes from the back of the periodic table now. So the ammonium ion is one of the only ones on your periodic table that's a polyatomic cation. So NH4 plus is the ammonium ion. And we write down chloride, and that's just a simple anion from your periodic table, and that's got the -1 charge, and so ammonium chloride is NH4Cl. Okay, one more. 44 is zinc nitrate. So we look up zinc on the periodic table. Zinc is one of the transition metals that only has one possible charge, +2. And nitrate, well, we've already looked that up. It's just above here, NO3, -1. And again, we're going to need 2 of those nitrate ions to balance out each zinc ion. So Zn, NO3, 2. Okay, now we come to table number 2, and this is where things get a little dicey because we need to use our periodic table, actually, not on this side. So for table number 2, we go back to the flowchart. Does it contain a metal? So in the first case, it's iron 3. Iron is definitely a metal. And is it polyvalent or multivalent? And as soon as you see a Roman numeral, you know that. You can also check that on the periodic table. Iron could be either +2 or +3. But it's actually the Roman numeral that tells us that this is polyvalent. So that Roman numeral 3 there indicates that the charge on the iron is indeed 3, and that can have more than one charge. So as far as our flowchart goes, we have it is a polyvalent cation. Does it contain a polyatomic ion? Well, in this case, each one of these things is this chloride, and if you remember, ides are just the simple ions. And so the answer there is no, so we come down here. So what we're going to be doing is writing the first atom symbol with the charge, and the charge is the Roman numeral, and then we're going to write the second atom with the charge from the periodic table. And then again, the charge on the anions has to equal the charge on the cations. So for this one, iron 3 chloride. So we need the symbol for iron as Fe. The charge here is +3. And then we write chloride, and chloride is Cl, and on our periodic table, the charge is -1. Now the charge on the anions has to equal the charge on the cation, so it's just going to be FeCl3. So 3 down below. Number 22, copper 1 chloride. So copper is Cu, the charge is +1, and chloride, we just did it up here, is Cl -1. And so copper 1 chloride is CuCl. Palladium 4 sulfide, number 23. Palladium on the periodic table is Pd. We know the charge is +4, that's the Roman numeral, so +4. And then sulfide on your periodic table is S, and it's -2. So the charge on the anions has to equal the charge on the cations, so we're going to put a little subscript here, a little 2 down below, and so the charge there is -4, and the charge is +4, and we can just rewrite that without the charges, so PdS2. And you're just going to go through up to question number 40 here, and then you can flip over on the back and check your answers. Okay, so we're on to table number 4, and it has both polyatomic ions and polyvalent cations. So we look at the first example here, iron 2 nitrate. So does it contain a metal? Yes, iron is a metal. Is it polyvalent? Well, we know that as soon as we see that Roman numeral, it definitely is polyvalent. And the last thing is there a polyatomic ion? So the answer to this question is yes, we definitely have nitrate and sulfate. So what we're going to be doing is writing the first atom symbol with the charge, using the periodic table, or using the Roman numeral rather, and then we're going to write the polyatomic ions formula with the charge. The charge on the anion has to equal the charge on the cation. And then basically we're going to put brackets around the polyatomic ion if there's more than one of them. Okay, so the first one, iron 2 nitrate, 61. Fe, 2 plus, is iron 2 ion. And then we have to look up nitrate on the periodic table. And just off the top of my head, NO3, -1. And then we have to make the charge on the anions equal the charge on the cation, so let's put some brackets on there, put a 2 on the outside, so it's Fe NO3 2. Let's take a look at the next one. The next one is copper sulfate, copper 1 sulfate. And so what we're going to do is write down the symbol for copper, Cu. The charge on it is +1, and then sulfate. And sulfate is SO4 -2 from the periodic table. The charge on the anions has to equal the charge on the cations. Actually, I didn't need brackets with this one. So it's going to be Cu SO4 -2, and a little 2 down there. So the -2, and we've got a charge of +2 on that side. You don't need brackets on this because there's only one sulfate, so that's why no brackets appear over here. Question number 63. 63 is gold 3 nitrate, so there's gold with a +3 charge. Nitrate, well, we just looked it up. It's NO3 -1. And the charge on the anions has to equal the charge on the cations. I've got 3 positives and 1 negative, so we'll put a 3 on the outside, and it's going to be gold 3 nitrate. Okay, and you're going to go up to the end of number 80 here, and then just flip over and check and make sure you got the right answer. Okay, now we're on the back, and we're going from the formula to the name, and we're using a flowchart as we did before. The questions are exactly the same. The difference is in what you're doing. Okay, instead of writing symbols over here, we're writing the names down. So the first one we're going to take a look at is table number 1. And table number 1 starts off with CaF2. And so as far as our flowchart goes, well, we can look at it. Look at the formula. Does it contain a metal? The answer is yes. Calcium is definitely a metal. Contains a polyvalent cation? Well, calcium is not. Calcium can only have that charge of +2, so we can use our periodic table to establish that. And we come down here, and it contains a polyatomic ion. Well, fluorine or fluoride ion is not polyatomic, so that takes us to this bottom right-hand corner here. So we're going to write the first atom's name, and then we're going to write the second atom's name with an IDE ending, and it's as simple as that. Okay, here we go. So the first atom is calcium, and the second atom is fluoride. Number 2. The first atom is sodium, and the second atom is chloride. The third atom, or the third example here, is barium. And then bromine becomes bromide. Remember, we're changing the ending to an IDE ending. Now, some students ask, well, how do I know not to use the Roman numerals here? Well, for the simple cations, for calcium, sodium, barium, and any other cation that can only have one possible charge, we don't need Roman numerals. Okay, we only need Roman numerals if an atom can have more than one possible charge. So basically what you're going to do is go through 1 to 20 and then flip the sheet over and on the back and just check your answers and make sure that the names that you wrote down are correct. Okay, we're on to table number 3 here, and in this case we've got simple cations and polyatomic anions. So using our flowchart here, and we'll take a look at this CaSO4 first. So the formula contains a metal. Yes, calcium is a metal. Is it polyvalent? Nope. Calcium can only have one possible charge. So we come down here and ask ourselves, does it contain a polyatomic ion? Well, as soon as you see a couple different atoms together here like this, like SO4 and O3, you know it's polyatomic. And so the answer here is yes. All we're going to be doing is writing the first atom's name, and then we're going to write the name of the polyatomic ion. And if you need to look that up, you can use your periodic table to do that. So the first one is 41, calcium sulfate. So SO4 on the back of your periodic table, and if you need to look it up, it's there, is SO4 with a -2 charge is right there. The second one just under sulfite. Okay, the next one is BeNO3. By this point in time, you know that NO3 is nitrate, so Be is beryllium. And nitrate is NO3 -1. So beryllium nitrate, as simple as that. Number 43 is ammonium is the first ion. and chloride is the second one. Okay, and what you're going to do is just continue from 41 to 60, and then flip over on the back and check your answers. Okay, on to table number 2. In this table, we have polyvalent cations, and I think this is going to be a little bit more complicated because we will need the periodic table for this. Okay, so the first one here, FeCl3. And let's take a look at our flowchart here. So does it contain a metal? Yes, it does. Is there a polyvalent cation? Yes, it contains iron. Is there a polyatomic ion? No, in this case we just have simple anions, so like chloride or sulfide. So here's what we're going to be doing. We're going to write the first atom's name, and then we're going to write the numeral to show the charge on the first atom. And then we're going to write the second atom's name with an IDE ending. Now the tricky part of it is right here, writing the Roman numeral to show the charge. So we know that iron on the periodic table could have a charge of +2 or +3. So the question is, what is the charge on this iron ion here? And the way we do that is we kind of go backwards. So we don't know the charge on the iron ion necessarily. It could be +2 or +3, but we do know the charge on the chloride. And on a periodic table, chloride has a -1 charge. Now we also know that the charge on the anions has to equal the charge on the cation. So the chloride ions, there's 3 of them. They have a total charge of -3. The charge on the iron must be +3 in order to balance that out. So this is iron. And then the charge on the iron is +3, iron 3 chloride. Again, let's take a look at the next one. Next one's CuCl. So number 22 here. So CuCl. Cu is copper. Copper can have more than one charge. You don't even really need to know what they are. On the periodic table, it's one or the other. 1 or 2. Okay. And so we know that chloride has a charge of -1, so we know here the charge on the copper must be +1 to make it equal 0. Remember, all compounds are neutral. So copper 1 chloride. 23. PdS2. And PD is palladium. And S is sulfide. And now we have to figure out the charge on the palladium. Well, we know that sulfide has a -2 charge. 2 times -2 is -4, so we know the palladium must have a +4 charge. Okay, what you're going to be doing is going through up to question number 40 and then checking your answers on the back of the table. All right, on to number 4, table 4. This one has polyatomic ions, and they're also polyvalent ions. And so on our flow chart, we start off with, do they contain a metal? Yes. Is there polyvalent cations? Well, the first example there was iron 3 nitrate or iron 2 nitrate. And so we know that for sure, and we know they're polyatomic ions, so all we're going to do is this. Write the first atom's name, write the Roman numeral to show the charge on the first atom, and then we're going to write the name of the polyatomic ion. And again, we're going to do the same thing to figure out the charge on the cation. We're going to use the charge on the anion. So let's see how that works out. So FeNO3 2. So FeNO3 2. So the first thing to do is to look up on the back of your periodic table the charge on nitrate. We know it's -1. 2 times -1 is -2. And we know that the charge on the iron has to equal that. So it's iron, and the charge on the iron must be +2. So 2 negatives, 2 positives, and nitrate. 62. Cu2SO4. The first thing to do, flip over on the back of your periodic table, look up the charge on sulfate, it's -2. We know that the charge on the anion is -2. The charge on the cation or cations has to be +2. But there's 2 copper ions here, so each one must have a charge of +1. So the total charge there is +2. Each copper atom has a charge of +1. So 2 times +1 is +2, and so we know this is copper 2 sulfate. We'll do a couple more examples here. Number 63, Au, NO3, 3. And Au is gold. We don't know the charge, +1 or +3, but we do know the charge on nitrate is -1. 3 times -1 is -3. We know the charge on the gold atom must be +3, so that's gold 3 nitrate. Okay, next one, number 64, and our last one, Ni, OH2. So we know Ni is nickel, and we know that OH is hydroxide. Okay, now what's the charge on the nickel? Well, we know on the Backer periodic table, the charge on hydroxide is -1. 2 times -1 is -2. So we know the charge on the nickel must be +2. You're going to go down there to the end of 80, flip over, and you can check your answers on the back. Remember, this is drill.